Hello, good evening to all. So, in previous classes already we have discussed Gauss law and its various applications to find the expression for electric field like uniformly or uniformly linear charge distribution, planar charge distribution, and how can one derive Coulomb's law by using Gauss law. Okay. And also we have discussed what is a solid angle, what is a surface vector, okay, and how to measure the electric field due to two parallel plane sheets. Okay. And this class is very interesting because here in this class we discuss mainly torque. Okay. We mainly discuss about torque acting on a dipole in a uniform magnetic in a uniform electric field. Okay. So, first thing already we have discussed what is a uniform electric field. Generally in a uniform electric field we represent the electric lines of force as parallel lines. In a uniform electric field generally we represent the electric lines of force as parallel lines. Okay. So, and dipole as we discussed that consists of two equal and opposite charges separated by some distance, and we take that distance as 2a. Okay. So, let us measure what is torque on a dipole, torque on a dipole in uniform electric field. Torque on a dipole in uniform electric field. Okay. So, first thing you have to know what is a torque. Okay. So, as all of you know, torque means it is a twisting force, or simply we can say twisting couple. Okay. Twisting force or twisting couple. What is twisting force and what is twisting couple? How can we know what is twisting and what is twisting couple? What is torque? Suppose I consider this one is a duster and I want to rotate that duster. Okay. So, in order to rotate that duster I have to make the force in two sides of the duster. Okay. So, in order to rotate the duster we have to make two sides, or we have to act two different forces in order to make twisting. Okay. Simply we can take example of your water bottle. So, the water bottle cap can be opened if we simultaneously act two different forces, and that force must be perpendicular to each other. Okay. And when two different forces, okay, perpendicularly act at some point, then they constitute torque. Okay. Two different forces act perpendicularly and the direction of force must be different. Okay. And when they act simultaneously at opposite direction, then they constitute torque, and because of that torque the object starts rotating. Okay. So, that is why we say it is a twisting. Okay. Because of this action of force the object start rotating. Okay. So, that is why you are able to open the cap of the bottle. We also able to rotate the screw. Okay. We also able to rotate the knot of any bolt. Okay. So, in all cases there will be action of a twisting force, and that twisting force is called torque. Okay. And otherwise is also called couple force. Okay. So, now let us measure what is the expression for torque in a uniform electric field. Okay. So, let us take first in uniform electric field. So, as we discussed, in a uniform electric field, the electric lines of force are straight and parallel. Okay. Suppose in that uniform electric field, the magnitude of the electric field is E. Okay. The uniform electric field that we take E. Okay. And in this uniform field, we have to place a electric dipole. Okay. Suppose we enter a electric dipole with some angle. Okay. Suppose this one is my dipole and I enter the dipole to the uniform electric field with some angle. Okay. That means the dipole makes some angle in the uniform or with the uniform electric field. Okay. Suppose this is the dipole. Okay. Okay. So, this is my electric dipole and length of the dipole, suppose I take AB. Okay. And the dipole length as we take, that is 2A. Okay. And the dipole is placed with some angle theta with the electric field. This dipole makes the angle. Okay. So, this dipole makes the angle theta with the uniform electric field. This angle is theta with the uniform electric field. Okay. So, now let us measure this the torque on that dipole. Suppose this one is plus Q and this one is minus Q. Okay. Plus Q and minus Q, their dipole length is 2A and that is entered within the electric dipole within the electric field with some angle of theta. Okay. So, when we measure the force, as we already discussed, when a charge enters to electric field, it experiences some force. Okay. When we enter a charge particle towards a electric field, it experiences some force. Okay. So, let us measure the force acting on plus Q and minus Q because of the electric field E. Okay. So, let us measure force exerted on plus Q due to E. Okay, electric field E, F plus Q equal to QE. Okay. Second thing, force exerted on minus Q. Okay, important is direction. F equal to QE. Okay, so that is positive sign. Positive sign means that force is along the electric field. Okay, so this is along the electric field. So that is F plus Q. Okay, so force on plus Q charge is along the direction of electric field. Okay, so F Q equal to that we can say plus QE. So that is along the electric field. So force exerted on minus Q due to E will be F minus Q equal to minus QE. Okay. So minus QE, negative sign indicates that force is opposite to the electric field. So that means we can say F minus Q is opposite to the electric field. So that will be F minus Q. So what is the net force on the dipole? Net force on the dipole F equal to F plus Q plus F minus Q. Okay. So net force will be QE minus QE. Okay, so that will be 0. Okay, so that means we can say when we place a dipole in uniform electric field, the net force on the dipole will be 0. Okay, so net force on the dipole we get, that is 0. Now come to the direction of force. Okay, if we look at the direction of the force, we find one force is opposite to the electric field, whereas another force is along the electric field. Okay, and if we measure, if we observe the force, okay, so if we observe the force, what we find, there is a perpendicular direction. Okay, and there is a perpendicular path between both the forces. Suppose that perpendicular path is C. Okay, there is a perpendicular line of action. Okay, perpendicular line of action between the forces, and interesting thing is that both the forces have the same magnitude. F plus q vector magnitude equals to F minus q vector magnitude equals to QE. Okay, both the forces have equal magnitude and has a different line of action. The line of action is also different. One is towards electric field and another one is away from the electric field. Okay, and they have a perpendicular line of action. Okay, so we can say when the force have equal magnitude and has a different line of action, then they constitute couple. Okay, and because of this couple, the dipole starts rotating like this. One is along this direction, another one is along this direction. So when they act simultaneously, the dipole starts rotating. Okay, again the force direction change. When dipole makes one orientation, what happens? Again the electric field direction changes and again the dipole starts rotating. So what happens? When we place the dipole in a uniform electric field, they experience the force which acts perpendicular to each other and have a different line of action, so they constitute torque. Okay, and the dipole starts rotating. Okay, and because of this rotation we can measure the torque, because torque says that, or definition of torque says that tau equals to force into perpendicular distance between the forces. Okay, so what will be the expression for torque? So here you may explain both the forces have same magnitude but different line of action, Okay, so they couple to each other. Thus moment of couple that is called torque. Okay, and torque equal to force into perpendicular distance between the forces. Okay, perpendicular distance between the forces. So that's why torque tau equal to F into, what is the perpendicular distance? This is the perpendicular distance that I have take here, AC. Okay, so F into AC. Okay, so let us measure AC from the triangle ABC. Okay, this is my triangle ABC. Okay, so if I observe the triangle ABC, this line is parallel to this line and AB acts as an intersector, and here if angle is theta, means this angle is also theta. Okay, like this angle is theta, this angle is also theta. Okay. So in ABC triangle, B angle is theta. Okay. So that's why if we take in triangle ABC, so what will be the result in triangle ABC? If I measure the sin theta, okay, so why we take sin theta? Because we know AB, okay, AB equals to 2A, and we want to measure AC. Okay. So AB is given, AC to be determined, so that's why I take sin theta. So sin theta will be AC divided by AB. Okay. So that implies to AC divided by 2A. So that will be AC equals to 2A sin theta. Okay. So AC will be 2A sin theta. So what will be the torque? So tau will be F into AC. So that will be F value QE into AC will be 2A sin theta. Okay. So that will be 2A into Q into E sin theta. Okay. So 2A into Q, that is called dipole moment, P E sin theta. So tau will be P E sin theta. Okay. But if we observe, tau is a torque, is a vector quantity, electric dipole is also a vector quantity, electric field is also a vector quantity, and between the two vector there will be angle theta. Okay, sin theta, the angle will be sin theta, and when in between two vector the angle will be sin theta, means it indicates towards the cross product. Okay. So that's why we can mention here tau equal to P vector cross E vector. Okay. So tau equal to P vector cross E vector, or simply P E sin theta n cap. Okay. So if we place, so what we get? If we place a dipole in a uniform electric field, then net force on the dipole will be 0. Okay. But it experience only torque. Okay. So uniform electric field, a dipole experience only torque. Okay. Not force, because force is 0. Okay. And if we measure the maximum torque, okay, so when the torque will be maximum, the torque will be maximum if we consider theta, if theta equals to 90 degree, then tau will be PE, and that will give the maximum torque. That means when the dipole enters to the electric field with 90 degree angle, then it will experience maximum torque. However, if theta equals to 0 or 180, okay, if theta equals to 0 or 180, in both case torque will be 0. Okay. So it moves either parallel or anti-parallel to the field, then it gives a 0 torque. Okay. So now let us measure the work done by the electric dipole. Another important thing is that in a non-uniform electric field, what is the behavior of the dipole? If I consider non-uniform electric field, okay, dipole experience both force and torque. Okay. In a non-uniform electric field, electric dipole experience both force and torque. Okay. So let us discuss about it. If we place a dipole in a non-uniform electric field, then as usual force act on the plus q charge and also force act on the minus q charge. Okay. So, as the field is non-uniform, so that is why the direction of force may be different, okay, and they must have a different line of action, okay, and in such case the total force or net force on the dipole may not be 0. So, there must be resolution, okay, there must be resolution between the forces. So, in such case the total force on the dipole may not be 0, okay. So, in a non-uniform electric field, the electric dipole experience both force and torque, okay, understand. So, in a uniform electric field, it experience only torque, force will be 0, and in a non-uniform electric field, it experience both force and torque, okay. So, let us measure the work done by the dipole, okay. Work done by the dipole in uniform electric field, okay. So, work done by electric dipole in a uniform electric field, okay. So, what we find in a uniform electric field, the dipole experience the torque, okay. So, what will be the value of torque? Tau, that is torque means it is a twisting force, okay. So, what is the experience torque? That means we can say when we place a electric dipole in a uniform electric field, it experience torque, and tau equal to we get Pe sin theta, okay, Pe sin theta, okay, and this torque is a couple action, okay. Suppose because of this couple action, the object we say it is rotating, means there must be angular displacement, change of angle from theta to theta plus d theta. Suppose I take there is a angular displacement of the dipole, because we are dealing with a twisting force, torque force. So, there must be angular displacement. Suppose the dipole from theta angle to displace to another angle theta plus d theta. So, change of angle will be d theta, okay, and because of this change of angle, so what will be the work done, okay. So, here we can say if the dipole displace through angle d theta, then work done dw equal to tau d theta, okay. So, work done will be tau equal to dw equal to tau d theta. If we make the dipole rotates to any other angle, if we enter to a 0 with some angle of 0, and if we makes that means from the position where it starts rotating, if I take as 0 and up to any point of rotation, suppose I take the angle theta, okay. So, what will be the net work done? So, net work done W will be integration dw 0 to w, okay. So, that implies to W equal to integration 0, suppose I take theta 0 to theta. So, substitute the value of dw, that is tau d theta. So, expression for tau will be P sin theta. So, that implies to W equal to integration 0 to theta Pe sin theta d theta, okay. So, that will be Pe sin theta integration, that will be minus cos theta from 0 to theta, okay. So, substitute the limits, Pe minus cos theta plus cos 0, okay. So, what will be the value of cos 0? That is 1. So, W equal to Pe into 1 minus cos theta. Okay, Pe into 1 minus cos theta. Understand? So, this will be the expression for work done for the dipole. Okay. So maximum work done will be done if we substitute here cos theta, that equals to, so what will be the value? So if we get 1, okay, then the value will be, work done will be 0. Okay. So if we substitute here theta equals to pi by 2, okay, so it enters or it rotates up to a half of the angle. Okay. So half of the angle means it will give PE, cos 90, that will be 0, so that will be PE. If it makes up to 180 degree angle, okay, so cos 1 it will be minus 1, so that will be give 2 times of PE. Okay, that case will be the maximum work. Okay, so if the theta will be 180, then it will give maximum work. Understand? So this is all about electrostatic as per your syllabus. Okay. So in electrostatic I make a review what we discussed from the starting. Okay. From the starting we discuss what is quantization of charge, okay, what is charge, what is quantization of charge, what is conservation of charge. Okay. So different various properties of electric charge, Coulomb's law, its vector form, okay, Coulomb's law in terms of position vector, superposition principle. Okay. Then we come to electric field for a point charge, okay, electric field for a group of point charge, electric field and force for a continuous distribution of charges. Okay. Electric dipole at tan A position, at tan B position, Gauss law, its application, and finally the torque on the dipole. Okay. So this is all about the electrostatic as your syllabus. Okay. So in next we do some problems on electrostatics. Okay. So everyone has to learn what are the basic formulas on this chapter. Okay. And that will help you to do the problems. Okay. Thank you.